Hello friends, welcome to the channel Chemistry Raghuveer. As I mentioned in my earlier video, there will be a video on calculation of nitrate, nitrite and sulfate ion. So here it is. So first starting with nitrate ion. For knowing the formal charge, we need to first draw its Lewis dot structure. Now how to draw a Lewis dot structure and the formal charge formula is already made a video on that. So you can go back to the videos and browse it as well. However, the link is provided at the end of this video. First, coming to the nitrate ion, the first step for drawing the Lewis dot structure will be knowing the valence electrons. That comes to be 24 electrons. Next, we have to identify the least electronegative atom among this. So least electronegative atom is nitrogen. Place it at the center, and the rest of the atoms surrounding it. Now I am placing here, and join these atoms with the central atom with a single bond. So these are the steps we need to follow. And so by drawing the single bonds, how many electrons totally we have utilized? Each bond comprises of 2 electrons being shared between these two atoms. So 6 electrons we have utilized. So leftover electrons are 18. Now we have to assign those rest of the electrons on the surrounding atoms such that it achieves the octet configuration. Now I am showing 3 pairs of electrons, that is 6 non-bonding valence electrons around this oxygen atom, so that it achieves octet configuration with these 6 electrons and 2 bonding electrons. Similarly, similar fashion can be attempted for the rest of the 2 oxygen atoms. So in this way we have made all oxygen atoms octet configuration. Now check how many electrons we have utilized here. 6, 6 and 6, 18. So completely we have utilized electrons and no more electrons to assign for the nitrogen atom. Next we have to check for the octet configuration of nitrogen. Did it achieve octet configuration? It is surrounded by 3 bonds, that means 3 bond pairs, that is only 6 electrons. So it is short of 2 electrons. In such case, we have to achieve the octet configurations for central atom by drawing the single bonds. So that can be achieved by making involve any of the 2 electrons on any one of these 3 oxygen atoms. Now I am showing here. So this is how octet configuration of nitrogen is made. Now reproducing the same structure here. So it appears as this, and finally we have to represent its charge by making a square bracket. So this is how we draw the Lewis dot structure. Based on this, now we will calculate the formal charge. You can follow any of these 2 methods. I feel convenient with going with the first method. You may also follow the other method. Now for calculating the formal charge, let us first designate this oxygen atom. So let's call this first oxygen atom, this as second oxygen atom, and this as third oxygen atom. Now for the first oxygen atom, let us calculate its formal charge. So number of valence electrons for this first oxygen atom, or for any oxygen atom, is 6, minus number of dots for this first oxygen atom are 6, minus number of bonds or lines it has is 1. So it comes to minus 1 charge. Similarly, for the second oxygen atom, valence electrons are 6, number of dots are 4, and number of bonds are 2. So this becomes 0. And for the third oxygen atom, so it is similar to the first oxygen atom, so it comes to minus 1. Similarly, we should also calculate the formal charge for the nitrogen atom. So nitrogen atom valence electrons are 5, number of dots, does it have any dots? No, so therefore 0, minus number of bonds or lines, it is surrounded by 4 bonds, 1, 2, 3, 4. So it acquires the charge plus 1. Now let us check for its net charge. Minus 1, 0, minus 1 and plus 1. So these 2 gets cancelled, left over is minus 1. So this is being verified. Now next, going for the nitrite ion. So nitrite ion is designated as NO2 minus. Now drawing its Lewis dot structure, first identifying its number of valence electrons coming to 18 electrons, and placing the least electronegative element at the center, and the least electronegative atom at the center, and placing the two other atoms surrounding it and joining them with the single bonds. So that thereby we have utilized the 4 electrons. Now leftover electrons are 14. So we have to assign these electrons on the each of the oxygen atoms such that it acquires the octet configuration. So I can achieve the maximum of 6 non-bonding valence electrons. Already there are 2 electrons are present, so 8 electrons, octet configuration achieved. Similar fashion can be attempted for the next oxygen. So we have utilized here 12 electrons. Leftover are still 2 electrons. So leftover electrons we have to place on the central atom. So finally we have to check for the central atom octet configuration. Now central atom has 2 bonds, that is 4 electrons, and 2 non-bonding valence electrons. So overall 6 electrons. That means it is short of 2 more electrons. So in such case we have to make a single bond, single covalent bond with one of the oxygen atom involving a pair of electrons. So now here I am showing as this. Now reproducing the same structure here, it appears as this and showing the charge. Sometimes it is also represented as this also, friends, because the double bond is delocalized. In such case we show as this. Now let's come to the calculation of formal charge, and the formal, for calculating formal charge, let us first designate these oxygen atoms. So now let's call this as first oxygen atom and this as second oxygen atom. So for first oxygen atom the charge appears to 1, second oxygen atom 0, and for nitrogen here I have to show. So number of valence electrons are 5, number of dots are 2, and number of bonds it is surrounded are 3. So it is equals to 0. Now the net charge will be equals to -1, 0 and 0 is -1. It's verified. Now going for the next ion, sulfate ion. Sulfate ion is a kind of special ion where it deviates from the octet rule. Now let us come across in the discussion. First, for calculating the formal charge, first we have to draw a Lewis dot structure. First step will be the identifying the number of valence electrons. It appears to be 32, and placing the least electronegative element at the center, that is sulfur, and the rest of the atoms surrounding it. Now I am placing as this. Now joining these atoms with single bonds. So by using the 4 single bonds I have utilized the 8 electrons. Now left over are 24. So these 24 electrons can be located on the surrounding oxygen atoms such that they acquire the octet configuration. Now let's check like this. So each oxygen atom is acquiring octet configuration, and we have utilized the 24 electrons. So no more electrons are left over to represent on the sulfur. Now this structure appears to be same as well. The central sulfur atom is also satisfied with the octet configuration. But check out, if there are 6 non-bonding valence electrons and 1 pair of bonding electrons, the charge on the oxygen atom appears to be -1. So on every oxygen atom there will be -1. So in such case it deviates from the charge what the sulfate ion has. So therefore we need to involve 2 of the bonds for the sulfur atoms with the oxygen atom, involving 2 valence electrons on 2 of the oxygen atoms as this. Now reproducing the same structure here. So it appears as this, and also we have to represent its charge. Now calculating its formal charge. So first we have to designate the oxygen atoms. So let us designate this oxygen atom as first oxygen atom, this as second oxygen atom, this as third, and this as fourth oxygen atom. So now here we come to know what are their respective charges. Finally, the sulfur atom. Sulfur atom, valence electrons are 6, and number of dots. Does it have any number of dots? No, 0. And it is surrounded by number of bonds or lines. So total number of bonds or lines are 1, 2, 3, 4, 5, 6. So overall charge is 0. Now let's know its net charge. -1, 0, 0, -1, 0 is -2. Let's verify. So this is how we draw the Lewis dot structure and calculate its formal charges. Hope you like this video, friends. Please subscribe, like and share. Thank you.